This episode is on mathematical induction. It is a procedure of proving an infinite sequence of statements at once. What the usual input of such procedure is, a sequence of statements. Could be some equations, could be some other form of statements. The key point is that they come labeled by natural numbers. So somewhere here's statement number n, and then it goes forever. So proving them all at once. Well, at once really is not literally true, totally true. What really induction does is first looks at the first statement. It's called the base of induction, and then you verify it by some direct means. Usually it's as a sequence of statements, the first member of this sequence is the easiest, and verifying it is not much of a deal. And then you have the starting point, and you want to progress to the first one, and after you check the first you have to check the second, and so on. So that's where at once come more or less applicable. You really assume that you're already at this point number n, and what you need to do is to move to the next one. So you need to have this implication from knowing that nth statement is true. You need, this is the shortcut for implies, follows from. You need to check the next one. So that is called the induction step. And these two ingredients are often of induction checked. Say first verified the base, and then for arbitrary n, for non-specified n, if you have this implication verified, then you have all the statements at once. There is a variant of this induction called strong induction, which differs from the previous scheme in the step place. For moving forward to the next step, you have to assume, it is convenient to assume that you already checked all the previous statements. Yeah, well, you do it anyway in the simple induction, and then you can organize an argument that the next in line of statements is also true. So that would be the strong induction step. And these are the variants of really the same procedure, because in both cases you really, sitting at this point, you really already verified, supposedly verified all the previous one. But sometimes it is enough just to assume the previous statement to conclude the next. Sometimes it is more convenient to assume all of them. So that's the difference between ordinary induction and the strong one. An example of this procedure is to follow. See you later.